So the homework. Using the same techniques that we learned in class, write a program that asks the user for their weight in pounds and then displays their weight in kilograms. The conversion formula is that. But that's too boring, just doing one conversion. So in addition, make your program solve the following tasks. We're just going to do a couple more. Task. Ask the user how many cows they have and display how many pigs they could trade for. Formula. 1 cow equals 3.5 pigs. So, task. Ask the user how much money they have and display how many hamburgers they could buy. Formula. Let's say their burgers are on sale for $2.99 a piece. So burgers is equal to money divided by $2.99. Okay, so just make one program that does all that. You don't have to write 3 separate .cpp files, 3 separate projects. You can just put them all in one. And so why don't we just do as a really quick refresher before we hit the next PowerPoint, one more conversion style problem. I did launch it, did I not? I guess I didn't. All right, so this one's going to be converting gallons to barrels, and I don't know what that conversion rate is. How many gallons are in a barrel of oil? 42. Okay. So our in-class task. Ask the user how many gallons of oil they have, print out how many barrels it is. And our formula is barrels equals gallons divided by 42. Wrong. Okay. So let's make a new project. Do our usual boilerplate stuff. Import IOStream at the beginning. So empty project, February 6th. Go to source files. By the way, if you can't see the Solution Explorer, just a reminder, you can always find it under View, View Solution Explorer. So right click on source files, add a source. I know everybody knows how to do it, but I say it aloud anyways. Source.cpp, I'm just going to keep the standard name. Alrighty. So our usual good stuff. What goes at the top? First line, import what? IOStream.
All C++ programs have that line at the top.
Yep, but it's not import. It's include. My mistake. Then using namespace std, just so that we don't have to prefix a whole bunch of things with std : : and then int main. Last part of our boilerplate will be for the non-Mac users system parentheses pause end quote end parentheses semicolon, and then after that return to 0. Why are you giving me grief? Oh, I forgot a semicolon. Here's a good example of what makes debugging fine. It's fun. It's underlining that, but where's the problem really? It's 2 lines up. Yeah. So I needed to fix that line. I'm just going to put a couple of marks there to indicate. Don't put those marks. Those are just to drag your eye when I have to fix typos. All right. No reason to run it yet. Okay, so what was our task? Our task was to ask the user how many gallons of oil they have, print out how many barrels they have. So, cout arrow arrow pointing towards cout. Let's convert gallons to barrels. \n end quote. Cout how many. Oh, I hate it when it pops up the thing covering the text I just typed. How many gallons of oil do you have? My answer would be 0, but all right, now I want to store, I want to let them type it in. I'm going to need 2 things. I'm going to need a variable, and then what kind of statement to store that value in the variable. Yeah, I'm going to use cin, but I haven't defined the variable yet. I'm going to make it a floating point variable so that people can type in 3.5 gallons. The best floating point type is double. So double gallons equals, I don't even need to initialize it. I'm just going to declare it. And then I'm going to use cin arrow arrow gallons in order to store their input into it. Cin arrow arrow gallons. Now we need to do our conversion. So all of that is input right here. Now some people like to declare all their variables at the top of a module, so you could cut double gallons and paste it up here. And by the way, if you want to fly around on the keyboard, the shortcut for highlighting an entire line, if I haven't mentioned it in the past, is Shift down arrow. That way you could cut a line really fast, Shift down arrow, and then Control X for cut, and you could go somewhere else and Control V to paste. All right, let's do our conversion. Double barrels. So barrels is equal to gallons. Anybody remember our equation? Divided by 42. Okay, cool. And then let's display our output. But let's put a few comments here too. Above my first cout statement, I'm going to put in / get input. And then above that conversion line, I'm going to put do conversion, and then I'm going to add one more comment at the bottom that says display output. So above that line, double barrels, I'm going to tack on another one that says do conversion. One more for output. Display output. Cout, you have space, end quote, barrels, arrow, arrow, quote, space, barrels of oil, exclamation point, \n, end quote, semicolon. Bless you. Okay, so that's a simple conversion. And your homework is to do 3 more conversions just like that. You could separate them with pauses, but you don't need to. It'd just be another set of, another get input, do conversion output, get input, do conversion output. I'm going to test mine, rebuild solution, so I clicked under build, rebuild. And I'm going to run it with the local Windows debugger. How many gallons of oil do I have? I have 100 gallons. That's 2.38095 barrels of oil. All right. Be kind of neat if we could round it up, right? So that'd be kind of neat. Another thing is if we weren't going to round it up, what if it displayed out to 20 decimal places? It'd be nice to kind of, chop it off at 2 or 3 decimal places. We'll learn how to do that later. Is there a ceiling function available to us to round it up? So ceil, C++. So inside the CMath library, there's a function called ceil, like ceiling, that rounds up. So let's give that a shot. But first I should wander around and make sure nobody has syntax errors. Let's do that.
Can you scroll down a little bit?
Yeah, sure. Let me, there. And if you ever get stuck, remember I can just print these things off and you can work them out. I ought to make y'all do your own conversion right on the spot.
Yes.
Oh, good deal. Cool. All right. If you don't mind, I'm just going to print it off for you. Okay. Who wants a copy? 1, I'll make 3. Okay. So remember, if you get stuck on a syntax error, you can always take a picture of the screen. By the way, I tried to send a text message out to the C++ class. Did you get a message saying bad weather?
Yes.
Who did not? If you didn't, then you might want to send me a text saying, hey, sure, here's that. Let me know. All right, I'm going to introduce the idea of constants. A constant is a value that can't be changed. Let me start the recorder. Oh, I left it running. Okay, so a constant is a value that can't be changed. Oh, I'm sorry. I didn't see your hand. I'm so sorry. I didn't mean to ignore you. Okay. So you see this 42 here? We could make that a constant. So let's come up to the top of our code, above the top line that says get input, but underneath the curly brace. We're going to do int const. That means constant. And we're going to call this one gallons underscore per underscore barrel equals 42. Now that's a long variable name, so when I go and type it, I'm just going to copy and paste it. Because I want to replace this 42 with that variable name. So now that I've typed that line, I'm going to copy that variable name. It's a constant now. You'll notice that I typed it uppercase separated by semicolons. The reason for that is that's just how people do it. You'll see it mentioned in the book that way. Does it mean you have to? No. Okay, so here's the change I made. I just added this line, and I changed this line. Then run it again and make sure it works. Now, why would you do that? Suppose the company decided later, your provider, that it was only safe to store 40 gallons per barrel. You could just change it in one place. That way, if we'd use that number 42, 17 times in our code, we wouldn't have to go through and change it every single time, right? Also, if you were looking at this line of code and the variable names weren't clear, like if it just said x is equal to y divided by 42, you'd have no idea what that 42 meant. But x is equal to y divided by gallons per barrel, being I know what that's doing. So it's better to give yourself good variable names, but for numbers like that, literals, I think we called it last Thursday, go ahead and define them as constants if you want to. I totally encourage that. So that was a great question. And I hope I didn't break anybody's code when you do that. Still works for everybody? Okay. Were we done with chapter 1 like I think we were? Yeah, I'm not going to start lecturing on chapter 1 for a third time. Okay.
Are we going to continue working on this one, or are we doing this?
I think, well, we may tack something else on, so let's not make a Dropbox for it and all that yet. So floating point types, remember the more bytes that the data type contains, the better the accuracy. So a float is a 32-bit type, which is a 4-byte type, meaning that it's just got 32, zeros and ones for every float that you declare. A double is 8 bytes, which is 64 bits. Now, who made up these values? Is it written in the Bible that a float is 4 bytes? No, but at one time there were no standards at all. And then since then, standards were created, standard bodies, and they decided that for now it'd be a good idea to say that floats were 4 bytes and doubles, which are supposed to be bigger than floats, were 8 bytes. And then a long double, for some reason, is the exact same length as a double. So from now on, I'm going to forget the existence of long double. Delete. So internally, they're stored in a form similar to scientific notation. If we remember what scientific notation is, that means that you have a mantissa and an exponent. So if you have the number 3.456, you would express that as 3.456 times 10 to the power of 0, I believe. In shortcut, you would call that 3.456E0. Now inside the computer, it wouldn't be, the mantissa wouldn't be expressed with a whole number in front of it. Instead, it would be stored like this, 0.3. I seem to have tacked on another 3 somewhere. Okay, so 0.3456 e to the -1. That's how that number would be stored inside the computer according to the IEEE standard, blah, blah, blah. Why does that matter? Well, if it's a float, it only has about 8 digits to store here. And if it's a double, it only has about 16 digits to store here. So what does that mean? What if you had this number? I'm just going to type in a number that's really long. And we wanted to store that in exponent form. Well, inside the computer, it's stored like this. If it's a float, it only has 8 digits of precision. So I'm going to count out 8 digits. 4, 5, 4, 5. Well, that's 4 digits. Let me just do this. 1, 2, 3, 4, 5, 6, 7, 8. It's stored like this. And then we have to figure out how many decimal places we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So e to the 19. That's how it's stored. That's a big difference, right? Because if we express this number back in standard notation, it would look like this. All zeros, right? Just like you chemistry and physics majors are used to the idea that you only have a certain number of digits of precision. So, you know, just because your scale says 3.49992 grams, your scale may not really be accurate, you know, to that. So you have to figure out the precision of your scale. And precision and accuracy are two different things. So, anyways, you see how this value, if we said x is equal to that, then by the time it's done, x is equal to about that. Not as precise. But a double can hold 16 digits in the mantissa rather than 8. So it would hold just about the entire number, or at least a lot more, you know, all but the last 3. So if you're using large numbers and you need that precision, you would want to use a double. And I just say use a double all the time. So all floating point numbers are signed. If you recall, we looked at integers, and there were 8 billion different types of integers, including some signed integers, and there were some unsigned integers. Okay, wow, we had to go back a ways. Have we done an hour-long lecture on binary and converting binary to decimal and stuff like that? Yeah, you 1113 students had to sit through that from me. I'm going to probably do it again. But yes? No? Doesn't sound familiar? All right. We'll wind up talking about that. So the bool data type. Java called it Boolean. C++ called it bool. All right. In Python, you had to capitalize true and false. In this language, you don't. So, you know, if you make the mistake, you run it, you get a syntax error, you fix it, no biggie. Bools are just small integers that hold zeros or ones, kind of like binary. But they're held in more than one bit. You know, all your data in your computer is rounded off to the nearest byte, pretty much. So the way that works is you store the result of a calculation in a Boolean as long as that calculation is something that gives you a true or false. So you could do this. Say you have, I'm going to make a temperature. Right now it's 23 degrees out there. So int temperature is equal to 23. I don't know if it really is. Bool is underscore freezing is equal to temp less than 32. So now bool is equal either to true or false. Is this expression true according to that variable definition above it? Is temp in fact? Yeah, that is true. So if we printed out bool, bool would be true. Excuse me, is freezing would be true. So if we had an if statement there that did something based on that, if is underscore freezing, cout burr, it is going to print burr because it is, you know. But if we change the temperature to something above 32, like if it's suddenly we get transported to Florida and it's 123 degrees, or the Yucatan Peninsula or something. So there we go. Is this variable, is this expression true or false now? It's false because 1, 2, 3 is not less than 32. So if this is false, then this if statement is not going to trigger because this is not true. So that's what you do with a bool. Some people call them flags. It's a flag. So just making some notes. Bool, Boolean, are variables that contain either true or false. Back in the oldest days of C, they did not have the Boolean data type, so what people would do would be this. # define the word true to mean 1. # define the word false to be 0, and then they could do, you know, if x equals true, like stuff like that. But far better now that we have a data type devoted entirely to that. Determining the size of a data type. In some places, like Java, or Python, you really don't care how many bytes the data is taking up. It's just a number, right? You know, enter your age. You type in 32. You don't care if age is, 4 bytes or 8 bytes or stuff like that. But there comes a time in our programming in C, where we do really care about the size of the data. And if that's true, you use a built-in function called sizeOf. So let's go back to our little program. And let's just get the size of the barrels variable. So int, I don't know, bytes is equal to size of parentheses barrels. And I'm putting this just above system pause. And let's print that out. Cout, arrow, arrow, bytes equals, space, end quote, arrow, arrow, the word bytes, followed by ENDL. Not END1, that's definitely an L. Now I said earlier that an int was 4 bytes. That better be true unless my understanding of the universe has been fractured. Let's run it. How many gallons of oil do we have? All right. So I have 3 barrels. Bytes is equal to 8. Now I said that bytes were equal to 4, but the mistake I made is that I forgot that we made barrels a double. That's double wide, so instead of being a float, which is 4 bytes, a double is 8 bytes. Okay, so here I was talking all big about not understanding the universe. Yeah, so I got it wrong. But that's because an int is 32 bytes, a long is a 64 byte or 8-bit. A float is 4 bytes, and a long is an 8 byte. Variable assignments and initialization. We have been doing this already. Once you create a variable, you can assign values to it. The equal sign is called an assignment operator. This assigns a value of 12 to the variable item. You can't reverse it. You can't say 12 is equal to item. You giggle, but I swear that when I walk around, I've seen people type that, and it's just because their brain likes to flip things. Variable initialization. When you declare your variable, you can also assign it a value. If you assign a value simultaneously with declaring it, it's called initializing. Now, colloquially, people will use the term initialize just whenever you first give a variable a value. And I'm guilty of the same thing. So if I do this, int count, and then later on I say count is equal to 32, I may accidentally mess up and say, okay, I'm going to initialize count to 32. No, it's only initializing if I do it in the same line where I declare it. Now, is there a functional difference? No, they both would have done the same thing, as long as there wasn't any data, any instructions between those two. But that is an initialization, as opposed to doing this, int x. That's a definition. I may be spacing on the exact technical term. And then x is equal to 32. That's an assignment. And then int x is equal to 32. That's a declaration. Not definition, declaration. That was the word I was looking for. So that's a declaration. We've declared our variable and then we assign a value to it. But if you do both at the same time, that's called declaring and initializing, or just initializing. Now you wouldn't do both of these, right? You wouldn't type in those two commands followed by this one. It would complain that that variable was already defined, so why are you redefining it? So in the year 2011, the C++ standards body decided it'd be really neat to create a variable type where you didn't know what it was. So if you wanted to, you could do this. Auto xyz is equal to 32. And then it would decide, okay, 32 is an int, so xyz is an int. And then if you did auto abc is equal to 3.14159, it'd go, okay, for abc to be that value, it would need to be a float. I've never seen a reason why I would use the auto keyword rather than just define it, right? Because that's an int. That's a float or a double. Why would I want to leave it up to the compiler to pick it for me? But if you want to, you could. Am I going to ask about the auto keyword on an exam or ask you to use it? No. Whoops, wrong one. So the auto keyword tells the compiler to figure it out itself. Determine the variable's data type from the initialization value. And I'm sure there's a real good reason for them adding it. Now scope. Scope is a mouthwash. No, wait. Scope of the variable is what part of the program in which it can be accessed. Let's go back to our little program here. I need to quit it so that I can make changes to it. Above that pause statement, down here at the bottom, I'm going to put an if statement. If barrels is less than 10, I'm just totally making this up here. Int need more is equal to 110 minus barrels. We're assuming, and this is a silly example, that we only have 10 barrels on hand, and so if we have more than, if the oil is too much to fit in there. Okay, and then we could print that out. Cout, gonna need more barrels, colon, end parentheses, or end quote, arrow, arrow, barrels, arrow, arrow, ENDL. All right, so if we enter a number of gallons that's less than 420, if it's less than 42, okay, my logic was backwards. Make that greater than 10. How about that? Change that line to greater, and I'm sorry for not having planned that out correctly in advance. But the real point of it is, even if I don't run it, is something about this variable right here. I'm going to test it, though. All right, so if we have 1,000 gallons of oil, it's going to say that we need 23.8 more barrels. I've made a mistake there, but I don't care. That should have been right there. Need more. So if you want to fix that line as well. Okay, the real point of that is that variable only exists between these two braces. If I tried to print it out here, or if I tried to do some math with it here, like don't type this because it's not going to work. Int x is equal to need more. I heard people typing. Don't type that because it's not going to work. It's underlining it in red because this variable need more is only valid between these two braces. It was declared between those two braces. It lives inside that brace. Gone by the time we get here. So its scope is this block of code. Scope, like you're looking at it like a hunting rifle or something. This is the only place you can see that number is in that block of code. Once you started looking for it elsewhere, you couldn't get to that variable. So that's what scope means. Scope is the block of code in which a variable is defined. We can use this one, barrels, all throughout the code. Because it's defined inside main, we can use it in here too, because it's still defined by the time we get in here, right? It's only when that opening brace that's up there at the top is closed that barrels does no longer exist. So I'm going to just comment that out. So if you did type it in, comment it out and say variable is out of scope and cannot be accessed. What if we really wanted to use it right down here? There's an easy fix. How could we modify the code so that need more is still in scope after the curly braces?
Make it a global variable.
and make it a global, just define it above the if statement. We could do this to get it to work. I could go and do int need more there, and then it exists by the time we get down here. It may not be initialized. I better initialize it as well, but that would fix it. I'm going to delete that line though because that would confuse the notes. So if you have a variable and you need it to share scope between more than one block of code, you make sure it's defined outside of both blocks of code. And what is a global variable? A global variable is that one that you define above main, and it's valid for every function in that file. So that would be overkill for this one, but I could define need more way up here, and it would be valid absolutely everywhere inside this CPP file. So very good point. A variable cannot be used before it is defined. So last class I had some code. Don't type this in because I'm going to immediately delete it. That looked like this. Input x, y is equal to x times 2, print y. That's what it looked like. And when I was wandering around, somebody's syntax error was that they typed the code in like that. What's wrong with it? Y has not been declared yet. Right? I mean, yeah, this looks like a language where you don't declare your variables to begin with. But even, you know, if we had to do that, you know, make it look a little bit more C-like, still not valid C. But, you know, why can't we use Y here? This would be an error, even if I corrected all of it to actually make it true blue C.
Y doesn't exist yet.
Yeah, Y doesn't exist yet because it has not been declared. Things happen in order, top down. We can't print out Y before we have it. You can't eat your can of SpaghettiOs until you actually have them. You know that phrase, you can't have your cake and eat it too? Well, if you're eating it, you have it. So yeah, I can have my cake and eat it too. I guess once I'm done eating with it, I can't have it. But it ought to be reversed. You can't eat your cake and have it too. Oh well. Anyways, don't know why that came to mind. So this program can't find its variable. Cout value, int value is equal to 100, but value is not defined yet. What if it's not, if it's defined, but it's not initialized? Let's play with that idea. So above system pause, I'm going to just declare a random variable, int x, y, z, and then I'm going to try to print it out. Cout arrow arrow x, y, z arrow arrow e and dl. We're trying to print out x, y, z. It says there were build errors. Would you like to continue and run? No, I don't want to run. I'm going to look for the fix for that. It says warning, initializing. Okay, that's not the big deal. Error, uninitialized local variable used. We try to use this variable before it is initialized. It has never had a value assigned to it. I wouldn't use the name initialize there because I just gave a lecture about how if you do them in two separate steps, it's no longer initialized. But you'd have to give this guy a value before you could print it out, either on that line or another one, right? Now it has a value. Now it could be printed out. But until it actually has some data, the compiler goes to a little bit of effort to try to make sure that it has some valid data. Now when you're working with arrays, as we will later, it doesn't go to that effort at all. But for simple variables like that, it does. You actually have to assign a value before you can access it to print out or to do math with it. Arithmetic operators. We know our arithmetic. Addition, subtraction, multiplication, division. That's the new one. Modulus. I know that 3/4 of y'all know what modulus is from fundamentals of programming. That just means remainder of. Have we already talked about this yet? I don't want to lecture on modulus again if we already spent 10 minutes on it.
I don't think so.
You think so?
I don't think so.
You don't think so? Okay, good. Thank you for telling me that. All right, so I use the childish names for them. Plus, minus, times, divide, and modulus. There's a couple missing that you Python programmers are used to. Python, you had that, floor division. We don't have that. In Python, you had star star, which meant exponents. We don't have that either.
On the PowerPoint, the division didn't leave decimal points in the chart.
If you divide an int by an int, you're not going to get an int. Very, very, very good point. Very good point.
So 7 divided by 3 is 2.
Yep. Unlike Python. Okay, so I guess let's do, for those who don't know Python, just ignore this part. But differences from Python, we don't have these operators. We don't have floor division. We don't have exponent. Also, integer division rounds down. What do I mean by that? If I did this, a is equal to 3 divided by 2, this is a whole number. That's a whole number. In Python, it would make it 1.5 because it doesn't round down. In this language, this equals 1. Java works the same way. So if you divide an int by an int, or if we want to say it more fancy, if both operands are an int, the result is an int, which means it will be rounded down if necessary. Okay, so if you have 3 divided by 3, I'm going to copy and paste that a couple times. 3 divided by 3, what's that? That's 1. What is 4 divided by 3? They're both ints, so what is that? 1. Right. 5 divided by 3 is 1. 6 divided by 3 is 2. Okay, cool. So, let's do some modulusing. Modulus means remainder. You use a percent sign. Three goes into 3 evenly, meaning there's no remainder. So 3 modulus 3 is 0. 3 does not go into 4 cleanly. There's something left. So 4 divided by 3 is 1 with a remainder of 1, not 0.333. People want to say that. So what is 5 divided by 3? It's 1 with a remainder of 2. And so 6 modulus 3 is 2 with a remainder of 0. Why did I type that? There we go. So that's how modulus works. All right, now that's if both numbers are an int. If you have this, x is equal to 3.0 divided by 2, or x is equal to 3 divided by 2.0, or x is equal to 3.0 divided by 2.0. Any of those answers will give us 1.5. Because one or both of those operands are floating point. So they're not both integers, so we'll not round down. We'll not turn it into an int. So whereas x is equal to 3 divided by 2 gives us 1 because both operands are ints. So division performs integer division if both operands are integers. If either or both is floating point, the result is floating point. And it doesn't matter what kind of data you're storing it in. If I did this, I want some high precision data. So my temperature is going to be equal to the formula for converting from Fahrenheit to Celsius is F is equal to C plus, or C times 9 divided by 5 plus 32. That's the formula for it.
Is there an
So-
order of operations to this?
Yes, there is. But we're going to kind of ignore that for the next 2 minutes, and then we'll hit order of operations. Okay. So that's our equation for converting Celsius to Fahrenheit. He's not good enough, though. Why is that? Now, it just so happens that 100 degrees Celsius is equal to 212 Fahrenheit. That's just the boiling point of water. Let's see if this equation would work out that way. F is equal to 100 times 9 divided by 5. And it's actually is going to work. Dadgummit. I'm going to rewrite my equation. No, I'm going to put parentheses around it. Pretend that that's going to make it better. It's actually going to make it far worse. Mathematically, it should still be a valid equation. But according to C and Java, it is not. So what's happening here? The parentheses are going to force this to be evaluated first. These are both integers. So what is 9 divided by 5 if they're both integers? 1. So 100 times 1 is 100 plus 32. So if we follow this equation exactly, we would say that 100 degrees centigrade is equal to 132 degrees F, which is wrong. To fix it, you just have to do that. Now, you may have thought, or I've had people ask, not being accusative here, that since you defined F as a double, it shouldn't do that rounding business. But the thing is that all of this happens first. And then and only then is it copied over here. So the way the compiler goes is, oh, I have an expression. I better solve that expression. And it follows its rules to the letter, and then it copies it into F. And yeah, since F is a double, it'll be stored as a floating point number, but it'll have been rounded down. So to fix that, we should probably remove the parentheses. And even then, the answer is going to be a whole number. And you might not want it to be a whole number, right? In which case, you should make 9 a floating point or 5 a floating point to make sure that it works. So order of operation is important. Good old PEMDAS, the rule that you learned in grade school or junior high or something like that. You can remember it as, please excuse my dear Aunt Sally. Or you can forget that and just remember the order of operations. Now, this language does not have an exponent operator. So it's now PEMDAS without the E. So P, parentheses. M and D, multiplication, division, and modulus. Just pretend that there's an extra M inside PEMDAS. And then A and S, addition and subtraction. That's the order in which expressions are evaluated. And there are order of expressions for other symbols besides these as well, like ands and ors and things, but for now, we care about the arithmetic. So this means that when we're looking at this expression, what gets done first? The stuff inside the parentheses. What gets done next? Any multiplication and division. Now this is all equal priority, and stuff of equal priority is just solved left to right. It's not that multiplications are all done first and then the divisions. So if we were going to do this, it would just multiply it by 9 first and then divide it by 5. Now that kind of looks like it's, anyways. So multiplication, division, and modulus are just done left to right. Addition and subtraction are just done left to right. So these 3 tiers, once you've gotten the scope solved based on the parentheses, multiplication, addition, and modulus are done first, and then addition. I said that wrong. These are done first, and then these. So let's just write a few expressions. 2 plus 3 times 4. 2 times 3 plus 4. 2 times 3 plus 4 divided by 2. 2 times 3 times 4 divided by 2. Okay, let's figure out what these are equal to. This first expression, which operator gets done first? Does, yeah, multiplication always happens first, so it's going to be 3 times 4, which is 12, plus another 2. So the answer to that one is 14. How about this one? Multiplication is still done first, right? So 2 times 3 is 6, plus 4 is 10, not 19. Alrighty, now we have parentheses, so we have to do this first. And inside that, which part do we do first?
4 divided by 2.
Yeah, 4 divided by 2, which is 2, plus 3, which is 5, and then 2 times 5 is 10. Same idea, we have to do the stuff in here first. Which one gets done first, multiplication or division? Yeah, multiplication. No. Yes. Sorry. I'll just trust that you know that these just happen left to right because they're all of the same precedence, right? So yeah, 3 times 4 is 12, divided by 2 is 6, times 2 is 12. And if we tried to reverse the order of these somehow, like that, it's not that that one would get done first. They're still done left to right. Now 3 divided by 4, unfortunately, rounds down to 0, so that would kind of throw the equation into chaos. I have that wrong now, don't I? 12 divided by 2 is 6, times 2 is 12. Okay. So that's the order of operations. Closer look at percent. We're going to have to slow down and get something uploaded real quick. The modulus operator computes a remainder from integer division. In this language, unlike some, both operands have to be integers. So it won't do modulus if one or both of them are floating point. Comments. Comments are those things that follow the slash slash. There's also a multi-line comment style. This is a single line. Slash star does multiple lines of comments. And when do you stop commenting? Star slash. In Python, you may have done multi-line comments with, quote, quote, quote. And then when you were done with it, you did quote, quote, quote again. In this language and in Java and a whole bunch of other languages, that's the multi-line operator. That's the single-line comment operator. What do you use comments for? Just to describe your program so that somebody else or you coming back to it later can understand what the heck it's doing. And if you go work for a company, they may very well have standards about how well you comment your code. And if you don't comment them well enough, you get slapped on the wrist, or people will throw tomatoes at you or whatever they do there. But they are ignored by the compiler. You can type in a whole bunch of code, and if it's commented out, it doesn't take any effect. So like if I went here and if I commented this code out, don't do this, and I'm going to undo it. But if I put a multi-line comment there, and then I close my multi-line comments there, it's showing all this as green now because it's gone. As far as the program is concerned, all of this is gone. It does not exist when it's compiled. It's just there for us to read. So you can comment out code if the code is buggy and you need to replace it or you don't need it at the moment. That's considered kind of shady, kind of poor. If you open up a file and half the code in it's commented, you're going to get annoyed because it's just visual noise to you. What is this doing? Oh, it's just part of the commented code. Doesn't help you understand it. But it's kind of seductive as well when you're working on something and you decide that you need to rewrite it. Your tendency, your urge is to keep the original stuff there and then copy it and paste it and fix it. I think that we're going to stop there. Indicate the purpose of the program, describe the use of the variables, explain complex sections of code. It's not a bad idea to comment what your variables are. Not at all. When I define gallons, that's a clear enough variable, really. But if I just called it G, I would definitely want to put a comment. Now don't do that because I'm going to just turn around and undo it. Gallons of oil, right? Put a comment there. If your variable name is at all ambiguous, put a comment. And that's about enough. Why don't we make a Dropbox for our stuffs? Make a homework assignment Dropbox. All right, so there is a homework 1 now, conversions, due a week from, Monday at midnight. And let's get ourselves a Dropbox for our in-class. Correct me, have we only done 1 in-class assignment? That doesn't sound right. This is our 3rd week here.
We've done 2 others.
We spent a lot of time in the PowerPoint.
Oh, and then they're broken up. Alrighty. I'll fix that. Alright guys, if you refresh your Dropbox, you'll see Dropbox C. Just go ahead and upload your source.cpp file there, and we are done, and I'll see y'all Thursday. And I'll walk around and help people. Just a second.
Are we going to do roll?
I'm going to take roll based on what people upload, so be sure to upload something. So, even if you didn't type in anything and you weren't going to upload something, upload a little document that says, I was here, But I think everybody types along. Yeah, go ahead and upload this previous one if you can.